Hi, I'm Michael Pfeiffer, Principal Consultant and Trainer at Industrial Metallurgists. In this video, I'm going to discuss designing successful products from the engineering perspective. From a business and marketing perspective, the common definition of a successful product is that it solves a real problem for a specific audience, it's well designed, it has good sales, good profits, and it's liked by the customers. From an engineering perspective, the definition of a successful product is that it meets performance and reliability requirements, it's low cost to produce, it's innovative and better than competitors' products, that the product development schedule, we meet the product development schedule and the product launches on time, and that things are set up with suppliers and in the manufacturing line so that the product is able, so that the company is able to meet the demand for the product. So there are a number of critical factors for achieving the engineering success. The first is there has to be a complete set of product design requirements at the beginning of when the product development begins. Second is using engineering processes and tools to help optimize components and the product to meet the performance and reliability requirements at the lowest possible cost, developing capable manufacturing processes, and selecting capable suppliers. I'm going to discuss all four of these critical factors. So the first is starting with a complete set of product design requirements. So this requires sitting down and reviewing the product and understanding the product and developing this set of requirements. It includes the product functionality, that is what functions and features it has, understanding the performance requirements, speed, power, appearance, and other ways that the functions and features are supposed to perform. Usability, if this is an electronic product, how will the user interface with it? We want to make sure that the product is easy to use. Physical features, what will be the shape, the size, and the mass of the product. Visual appearance, for many products, colors, contours, and other things that affect the aesthetics of the product are important. Reliability, this refers to the stressors, that is the conditions that can cause the materials in the product to degrade, and the testing that will be performed on the product to make sure that any degradation that does occur will not affect the performance of the product. That is, that the product will have the desired reliability over the life of the product. Safety requirements. Maybe want to make the product out of non-toxic materials, have it be free of sharp edges, or be able to withstand a certain amount of force. These will all influence decisions made during design. Sustainability, energy consumption of the product, or use of recycled materials, or recyclability of the materials in the product. Again, these will all influence the design. So having all this information up front is very important because all these different requirements will influence design decisions, designing the components that are used in the product, how those components are fabricated, and the specifications for the components, and the fabrication, and also the joining of the components. The next thing is using engineering processes and tools that enable optimization of the components that are used in the product, as well as the product, in order to meet the performance and reliability requirements at the lowest possible cost. So this includes using things like computer-aided design, finite element analysis, and design failure modes and effects analysis to aid with engineering decisions. Second is cross-functional collaboration. So typically design engineers are mechanical and electrical engineers, and also software engineers for an electrical product, but also help from materials engineers for help with material selections for components and for ways to fabricate components. Input from manufacturing engineers about how components should be designed for ease of fabrication and ease of joining, and also input from reliability engineers to get their input about how the product and components will be tested, and getting their input when tests are performed to make sure that to understand the effects of the testing on the product and use that information to make changes to the design. And that's also testing and design feedback. Testing the product both from a functionality perspective as from a reliability perspective, and then using that information to make changes to the design. And finally, design for manufacturing. Making considerations when designing components and designing subassemblies and designing the entire product to make sure that all of these are easy to manufacture so that there's no problems, quality problems, or delays in meeting schedules. The next thing that's important is developing capable manufacturing processes. And this again involves design for manufacturing. So designers should be talking with materials engineers and manufacturing engineers to understand their requirements and make sure that they're designing components and subassemblies that are easy to manufacture so that they're lower cost to produce, will have good quality, and there won't be problems meeting schedules or demand. And finally, we want to make sure we select capable suppliers. First thing that's important for selecting capable suppliers is writing thorough materials, components, and subassembly specifications. It's important that the suppliers understand what they'll be making and the requirements so that they can understand how to quote the product or how to quote the thing that they'll be making, and to make sure that there's no surprises to them. Also, again, design for manufacturing, make sure that whatever people are going to be supplying to you will be easy to produce. If it's a hassle for a supplier to make something, let's say it hasn't been designed, a component has not been designed for ease of fabrication, then they will increase the cost of fabricating that component to you. And if it's too much of a hassle, then capable suppliers won't even bother quoting it. And that's part of selecting capable suppliers, is if you see that your preferred suppliers are not quoting components or subassemblies, then it could be because they realize it's going to be a hassle to produce those things and they don't want to deal with it, and you may be left with having to work with less than capable suppliers. And finally, cross-functional collaboration. Get input from your suppliers to make sure that the things you're designing and the materials you're selecting are reasonable and that are easy for them to get to you. If it's not, you could have problems getting the material or making sure that you get the materials in according to your schedules. So in summary, engineering a successful product means meeting performance and reliability requirements. It's low cost to produce. It's innovative and better than competitors' products. You're able to meet the development schedule and launch the product on time, and you're able to meet demand. And the critical factors for achieving these things is having a complete set of design requirements at the beginning of product development, using engineering processes and tools to optimize components in the product to meet performance and reliability requirements at the lowest possible cost, developing capable manufacturing processes, and selecting capable suppliers that are capable of consistently providing their product to you, product that meets your requirements. So there are a number of things that have to happen. So that's what I have to say about developing successful products from an engineering perspective. If you have any questions, feel free to email or call me. And we have lots of courses on our website if you're interested in learning more about metallurgy. And if you like this video, sign up to be a subscriber to our YouTube channel. Thanks again for watching. Bye.